A while ago I came across this awesome 2.5D action adventure inspired by 90s and 2000s anime, and as it turns out it was made using Unreal Engine 5, Paper 2D with Paper ZD, and the lead developer Zach is a longtime viewer of this channel. While working on this game with his team studio Genki, they developed an amazing 2D-3D hybrid look that is quite different from Octopath and the projects I usually work on, and they found great solutions to many issues I haven't even had the time to look into yet. And since Zach wanted to give something back to the Unreal 2D community, he was kind enough to give me a behind-the-scenes look into their workflow and the 2.5D techniques they used or developed, so there's a lot of information here that might help you with your own projects as well. First of all, the game you're seeing is called MythicTale, and the Steam page just went up recently, so make sure to wishlist it and show your support from the link in the description. MythicTale actually started out as a project just using C++ and some graphics libraries, but after coming across my content on YouTube and Udemy, they decided to switch over to Unreal Engine 5 and Paper ZD. And Paper ZD really helped them improve their workflow since anim overrides and anim jumps made implementing the combat logic a smooth process. They've built a combo component which allows them to hold an array of structs that define information about which flipbook to use, how much damage to apply, and even the root motion for each attack. For example, giving the punch some forward momentum, while for the kick your character just stays in place. To achieve that root motion with sprites, they're actually using my little plugin that exposes the built-in root motion function of Unreal Engine to blueprints, since it's usually only available with C++ or if you're using the gameplay ability system. And this node isn't only used for the attacker's movement, but also to apply knockback to the victim, to knock them into the air, and also knock them back down to the ground. For hit detection, they're using box traces instead of having a box collision always attached to the actor. This allows them to easily determine the start and end of a hitbox, and opens up the possibility to add more reach to certain attacks through character progression. The hit result is then used to spawn particle effects, shake the camera, and apply damage through a custom logic that doesn't rely on Unreal Engine's built-in damage system. This allows them to easily change the hit reaction based on if the attack was a melee attack, projectile, or damage from the environment. When it comes to visuals, they're aiming to recreate an art style resembling the Game Boy Advance and Nintendo DS era of gaming, with the 2.5D Pokemon games being the main inspiration for how they built their environments. But instead of simply recreating that style, they wanted to take things a few steps further and added their own spin on things. All art assets are created in-house either by Zach or other members of Studio Genki. For pixel art animation, they use Sprite with a traditional frame-by-frame approach, having drawn over 1000 frames for the main character alone. Zach also said that they're quite happy with the Sprite to Unreal Engine workflow, and they opted for using the JSON import technique that I also used in my tutorials and courses. For them, the JSON technique was a lifesaver because they could not imagine having to create each flipbook in Engine with the sheer amount of sprites this game requires. He said that they also looked into the Sprite importer plugin that I've also been playing around with, but since it's not available for Mac OS for now, they're sticking with the JSON method. To create the 3D models you can see in the environment, they're using Blockbench since it allows them to accurately control the pixel density of their textures. With Blockbench, you can define the size of your meshes by pixels, which then automatically sets the UVs for the pixel art texture to the correct size. Blockbench also has an auto UV feature which will match the face's size in pixels, and a project from view setting, which is very handy when trying to wrap UVs so they look correct from an angle. While Blender would also be a valid option, these features made them prefer Blockbench over it. For the environments, they initially used Unreal Engine's built-in landscape tools, but after playing around with them for a little while, it turned out that they were not a good fit for the art style they were trying to achieve. For roads, they just ended up using tile sets and Unreal Engine's built-in tile map system by just drawing out these paths and placing the tile map slightly above the ground. For 3D terrain, they tried a few different methods to create 3D tile maps and ended up sticking with the tiled level plugin by Puff Studio, which does have a few limitations but overall has been working quite well for them. The workflow is quite simple, and you just have to create your 3D tiles, import them into the engine, create your tiled item set, and then you can either create your auto tile settings or start to place tiles manually. And if I might add, I believe all of this attention to detail when creating the pixel art and models really shows in the final look of the game. For comparison, while I do love the Octopath series, things can sometimes look quite sloppy with pixel sizes being all over the place, leading to an incoherent look. So MythicTale really achieved something special here with their visuals by keeping pixel sizes consistent. Next up, they showed me their after image or ghost trail system, which is something I was quite interested in since I've also been experimenting with this for a possible future tutorial. And it turns out their way of achieving this is quite similar to what I came up with, and they created a component with a pooling system that can activate and deactivate sprites, set the color, lifetime, and so on. This allows actors to be reused by just hiding and showing them instead of constantly creating and destroying actors, which can be expensive and could possibly lead to hitches when garbage collection kicks in. To make the sprites appear closer to how they were drawn, the characters and trees do not stand upright, but are actually facing the same angle as the camera, which is achieved through a custom billboard material they created. But rotating the sprites like that led to another issue, and that is the characters clipping through objects in the environment. To solve this problem, they came up with a work in progress solution using a custom shader which sets the sprites as an opacity mask for object materials to just not render that part and make the character show up unobscured. When it comes to particle effects, they've also cooked up something special, and instead of using effects that rely on textures and static meshes, a lot of their effects are entirely created through math, which allows them to create many different shapes by just changing a few parameters in Niagara. Their approach is inspired by a paper by Paul Borke called Supershape, which breaks down these formulas. And currently, they're also working on releasing this PixelFX particle system on Fab, but they still want to add a few more examples and documentation before publishing it. So stay tuned and follow @GenkiAU on Twitter for an announcement if you're interested in getting it. I hope this gave you an overview of what kind of problems needed to be solved to create a game like this, and this might also give you some ideas of how to overcome issues which you've been stuck at with your own games. Just like me, Studio Genki believes that Unreal is a great choice for these 2D 3D hybrids, and as long as you know which features to turn off and how to apply some tweaks, performance isn't really much of an issue. So a big thanks to Studio Genki and Zach for giving us a behind the scenes look. I'm personally really looking forward to MythicTale both from a player's perspective and also to have another great and unique example of what kind of awesome 2.5D games can be created with Unreal Engine 5 and PaperZD. Again, don't forget to wishlist MythicTale from the link in the description to support the developers. As always, a huge thanks to my awesome patrons and YouTube channel members.